Okay, last lesson, sum of infinite sequence. So this is an example where a sequence will eventually get smaller and smaller and smaller and smaller, so that you're eventually getting so small you're kind of almost adding 0 on. Okay, so this works when your R value, your absolute of R, is less than 1. So it could be negative a half or a half, something like that. Okay, so sum of this whole sequence equals the term 1 over 1 minus R. Okay, so this entire sequence would add up to, term 1 is 8 over 1 minus, what is our ratio here? What are we timesing by? 1/2. Okay, so evaluate the bottom first. So 1 minus a half is 0.5. Okay, now 8 divided by 0.5 ends up being 16. Okay, let's do another example. 4/3, 1 3/4, etc. Okay, so we don't really see the R, so I'm going to take a term, divide it by its previous term. So 1 divided by 4/3 equals 0.75. So every time we're timesing by 0.75. So sum of the entire sequence is going to be the first term over 1 minus R. Okay, evaluate the bottom first, which is 0.25. And now 4/3 in brackets divided by 0.25 equals, the entire series will eventually kind of cap off and add up to 5.33. Okay? Just checking here, let's look at this. 8 plus 4 is 12, plus 2 is 14, plus 1 is 15. Now the next number is going to be a half, which adds up to 15.5, and then the next number would be a quarter, so that's 15.75, then an eighth, and then a 16th. So can you see that eventually your numbers adding are so small, it's going to fizzle out and eventually cap off at around 16 as the sum of the entire sequence. That's what's happening there.